At the cold, lonely edge of our solar system, nearly 2 billion miles from the Sun, hangs a world that shouldn't exist: Uranus. Often the forgotten sibling of the gas giants, Uranus is a planet of contradictions. Unlike any other world in our celestial neighborhood, it doesn't spin, it rolls. Tilted at a staggering 98 degrees, likely the result of a cataclysmic collision with an Earth-sized object billions of years ago, Uranus spends its 84-year orbit, essentially lying on its side. The consequence is a calendar measured not in months, but in human lifetimes. For 42 years, one pole burns under a sun that never sets, while the other drowns in a darkness so total and so cold it makes Antarctic winter feel tropical. Then, with geological indifference, the light shifts and the frozen pole inherits the blaze. Shrouded in a thick mantle of methane that absorbs the red wavelengths of light and bleeds this eerie blue-green hue back into the void, Uranus hides a far more violent interior. Deep below these colored clouds, the crushing weight of the atmosphere forces chemistry to stop following the laws we know on Earth. Hydrogen becomes metallic. Carbon, under sufficient compression, doesn't dissolve or drift. It crystallizes. It falls. If the models are right, Uranus may be a planet where it literally rains diamonds, slow and permanent, sinking toward a core we've never seen and may never reach. But the strangest detail isn't buried in the interior. It's orbiting overhead. Uranus has 27 moons, and while the names of ancient gods govern the rest of the solar system, these moons belong to the poets, especially Shakespeare. Among these, one tiny, fractured speck has recently shattered everything we thought we knew about the outer solar system: a moon called Miranda. We often explore the future of humanity and the idea of living beyond Earth. But what if the real challenge wasn't building a home on another world, it was rebuilding our own after a series of catastrophic events? To do that, we would need the book, The Ultimate Guide to Rebuilding Civilization. They say you shouldn't judge a book by its cover, but this one makes a very strong first impression. And when you open it, you realize it's not just a guide, it's a celebration of the entirety of human civilization. Whether you simply enjoy learning how things are made and how they work, or like to take apart the very systems that have propelled our species forward, there is something in here for everyone. Within these beautifully illustrated pages are detailed diagrams on everything from materials to building to industry. Anything humans have made or engineered is in here. Also, it contains a hidden quest, a secret puzzle that adds a layer of interactivity. I've been reading it for about a week now, and it's a really well-made piece of work. It's also the kind of thing you'd gift yourself, or that one friend who's impossible to shop for. Check it out at the link in description, and use the code TERRITORY for 10% off. In January 1986, NASA's Voyager 2 became the first and only spacecraft to get a close-up look at Miranda. The images that beamed back to Earth stunned the scientific community. Miranda looked like a Frankenstein moon, a patchwork of mismatched geological features that seemed to be stitched together from different worlds. Deep grooves, towering ridges, and massive trapezoid-shaped regions known as coronae dominate its surface. For decades, the leading theory was that Miranda had been smashed into pieces by a colossal impact and then pulled back together by its own gravity, creating this jumbled, scarred appearance. But to truly understand the scale of this moon, you have to look at Verona Rupees. It is the tallest cliff in the solar system, a sheer vertical drop of nearly 12 miles. To put that in perspective, if you were to stand on the edge and jump, you wouldn't just fall, you would drift. Because of Miranda's low gravity, it would take you a full 12 minutes to reach the bottom, plummeting through a silent, airless abyss before finally making impact. Now, for 40 years, Miranda was considered a dead, frozen relic, a cold case in the files of planetary science. But recently, a team of researchers at the Johns Hopkins Applied Physics Laboratory found something that changes that. Armed with modern computing power, the team went back to the Voyager 2 archives and stripped away decades of assumptions to reveal a new reality. By mapping the convoluted surface features and simulating different internal structures, they discovered something startling. The Frankenstein look wasn't from an impact, but likely caused by something much more dynamic, an internal ocean. Their findings suggest that between 100 and 500 million years ago, Miranda likely harbored a subsurface sea at least 62 miles deep. To put that in context, Europa, Jupiter's famous ocean moon, has a subsurface ocean estimated to be between 60 and 150 miles deep. Miranda, a moon less than 300 miles wide, may have rivaled that. For a body so small, that is extraordinary. And it raises an immediate question. What kind of ocean are we actually talking about? Scientists believe it isn't pure water. At those temperatures and pressures, it is likely a dense, ammonia-rich brine, a chemical cocktail that dramatically lowers the freezing point of water, allowing it to stay liquid, even in brutal cold. Ammonia-water mixtures can remain liquid at temperatures as low as -107 degrees Fahrenheit. In the outer solar system, that's the difference between a dead rock and a potentially active world. This isn't a small detail. The chemistry of that ocean would have dictated everything: its longevity, its internal dynamics, and critically, its potential as a cradle for life. But how does a moon that sits in a -350 degree Fahrenheit environment keep water from freezing? The answer lies in a cosmic dance of gravity. Miranda is caught in what scientists call orbital resonance. The gravitational pull from Uranus and its neighboring moons, like Ariel, constantly squeezes and stretches Miranda. This tidal heating creates friction deep inside the moon, generating enough heat to melt ice and maintain a liquid sea. This discovery catapults Miranda into a very exclusive group of ocean worlds, joining the likes of Saturn's Enceladus and Jupiter's Europa. And where there is liquid water, the conversation inevitably turns to life. This moon at the edge of the solar system just got very, very interesting. If Miranda's ocean existed for hundreds of millions of years, it could have provided a stable environment for complex chemistry to emerge. Deep on the seafloor, hydrothermal vents, fueled by that same tidal heating, could have pumped minerals into the water. This is exactly how life is thought to have begun in Earth's own deep oceans, far away from the reach of the sun. On Earth, entire ecosystems thrive around hydrothermal vents at the bottom of the ocean. In complete darkness, under crushing pressure, sustained entirely by chemical energy rather than photosynthesis. These ecosystems of bacteria, tube worms, and crustaceans are powered not by sunlight, but by a process called chemosynthesis. Life, it turns out, doesn't need a star to survive. If life can do that on Earth, the same blueprint could, in principle, work on Miranda. The key ingredients: liquid water, chemical gradients, and a sustained energy source may all have been present. There's also the question of time. Hundreds of millions of years is not a short window. For reference, the first complex multicellular life on Earth appeared roughly 600 to 800 million years ago. If Miranda's ocean persisted for even half that duration under the right conditions, the timeline for chemistry to cross into biology isn't as far-fetched as it might seem. Astrobiologists refer to this as the habitability window. Miranda's may have been open longer than we ever imagined. Even more tantalizing is the possibility that this ocean hasn't completely disappeared. The team believes that if Miranda had frozen solid, we would see massive cracks and expansion features on the surface that simply aren't there. This suggests that Miranda's interior is still partially liquid, a thinner, hidden sea that may still exist today. While it is too early to say for sure, if something is swimming in those dark Uranian depths, the potential for habitability on such a distant, tiny moon is mind-blowing. But the problem is, we have reached the limit of what 1980s technology can tell us. We are, quite literally, squeezing the last bit of science from Voyager 2's aging images. To solve the mystery of the Miranda anomaly, we have to go back. Because tiny, broken, and sitting on the edge of the dark, Miranda might just be holding the key to understanding how life can survive in the most extreme corners of the universe. What do you guys think? Comment below to let us know. If you enjoy our content, kindly consider supporting us by becoming a member. And don't forget to subscribe to Territory, because this is your space.